Hi all, welcome to the Cloud Magica. We are in second session of module 4. In last session, we discussed about Hadoop 1.x and limitations of Hadoop 1.x. Now, let us start with YARN. Hadoop 2.x is the advanced version of Hadoop 1.x. Earlier version of MapReduce framework in Hadoop 1.x is called MR1. The new version of MapReduce is known as MR2. The new model is more scalable as compared to the earlier MR1 system. There is a big shift in architecture level from Hadoop 1.x to Hadoop 2.x. Hadoop 2.x removes the problem of cascading failure, multi-tenancy, and no high availability unutilized data in HDFS. So these problems are handled by Hadoop 2.x, and also backward compatibility is there. So if you are using old code, then still existing MapReduce job can run on Hadoop 2.x and without any change, but yes, with some warning. Yarn is a re-architecture that allows multiple applications to run on the same platform. This component allows to run application beyond the MapReduce. Hadoop 2.x has multiple name nodes. So one will be in active mode and other will be in standby mode. All the data from active name node is written to the shared edit log, and from here the standby name node reads the data so that active and passive name node should be in same state. The job of secondary name node did not change. Still, it does the same thing as it did earlier in Hadoop 1.x, and we know very well that secondary name node is not a standby for the active name node. So if active name node will go down, then another standby name node will handle everything because standby node is having shared edit logs. Hadoop 2.x provides high availability because there is no data loss, since if name node fails, then standby name node are available. Yarn component. Just see the flow carefully. So the yarn system has the following components: global resource manager, node manager, application specific application master, scheduler, and container. I will request you to note down all the yarn component name in your notebook and try to fit in your mind, or just stick it somewhere and see your note on regular basis. So let's compare MapReduce 1 and yarn component. So in MapReduce 1 we have job tracker, and in yarn we have resource manager and application master. So resource manager plus application master is equal to job tracker. Another one is task tracker. So task tracker is equivalent to node manager, and slot is equivalent to container. I will try to explain all the yarn component in detail because you have to understand it very clearly, and you will not be able to understand it clearly if you will not put your 100% focus. I will request you to listen the video 2-3 times very carefully. Once you understand yarn component, then you will feel very confident, and anywhere you can talk about Hadoop. I will try to explain each line in 2-3 ways. I will try my best and will use all the possible way to make you understand. But still, if something is not clear to you, then kindly drop me a mail. So let's move forward, and now let us understand yarn component one by one. In layman term, we can say that container represents a collection of physical resources, means CPU cores, disk along with RAM on a single node at a given cluster. A container is supervised or controlled by the node manager and scheduled by the resource manager. A map reduced task run on a set of container, and each map or reduce function runs on one container. The relationship between a container and a node, this is basically our node. So the relationship between a container and a node is just like one node can run several containers, but a container cannot cross a node boundary. There can be one or multiple containers on a single node. So one node can have one or more containers. Or we can say that every node in the system is considered to be composed of multiple containers of minimum size of memory is greater than or equal to 1 GB and less than or equal to 8 GB. The application master can request any container as a multiple of the minimum memory size. Make it simple. In simple terms, container is a place in your Hadoop cluster where a YARN application is run. It is available in each node. Scheduler is one of the component of resource manager. Application master is responsible to negotiate container with that scheduler, and node manager is responsible to launch the containers. So what we have written here, we have written container is a place in your Hadoop cluster where a Yarn application is run. It is available in each node. So, container will be available in each node. Second point is, scheduler is one of the component of resource manager. So, scheduler will be component of resource manager. Another point, application master is responsible to negotiate container. Application master. This is basically takes the responsibility to negotiate containers with the scheduler, and node manager takes the responsibility to launch the containers. Let's understand the responsibility of node manager. Node manager runs on the slave nodes of the cluster and get the request from the resource manager and allocates or assign containers on behalf of the job. Node manager launches the container and takes the responsibility to manage the life cycle of each launched container. So, node manager is responsible for monitoring and reporting resource usage metrics in terms of consumed memory and consumed CPU of individual container to the resource manager. Resource manager along with node manager are responsible for handling the resource allocation on the Hadoop cluster. So what we said basically, resource manager along with the node manager. So these two, resource manager and node manager, are responsible for handling the resource allocation on this Hadoop cluster. So we can say that node manager is a per node agent which takes the responsibility for managing the health of individual nodes in the Hadoop cluster. In another way, we can say that a node manager runs on a single node in the cluster, and each node in the cluster runs its own node manager. It means one node will have one node manager and all nodes will have node manager. So what I have written? I have written this node manager will run on a single node in the cluster, and each node in the cluster runs its own node manager. Means this node will be having its own node manager, this node will be having its own node manager, and this node will be having its own node manager. It means one node will have one node manager and all nodes will be having node manager. So there will be basically one to one relationship. It means if one node is there, it means one node manager will be there. If 10 nodes are there, then 10 node managers will be there. This node manager acts like a slave and it takes requests from resource manager and allocates container to the application. When a node boots up, this node manager registers with the resource manager and informs the resource manager that how much resources are available with me to form a container. At runtime, node manager continuously updates this information to resource manager because the node manager and resource manager works together to ensure an optimized and fully functional cluster. What basically we have written at runtime, node manager continuously updates the information to resource manager because these two works together to make the fully optimized and functioning cluster. The node manager does not contain any knowledge of the individual application. This will not contain any kind of information about the individual application. This responsibility is handled by a different component that is called application master. Do not mix and do not get confused between node manager application master and resource manager. So basically do not get confused with all these three concepts. Understand it very carefully. Let's move to application master. So there is one application master per application, which is there is one app master which is application specific or framework specific. We can confidently say that application master is the key differentiator between the new yarn and other MapReduce version 1 framework. The application master runs in containers that are created by the resource manager on request, and application master is responsible to manage each instance of an application that basically runs within yarn. The application master takes the responsibility to negotiate the resources from the resource manager. What I've written, the application master is responsible to negotiate the resources from the resource manager, and application master is the responsible component to monitoring the execution and resource consumption of containers through the NodeManager. So what basically we have written? This application master is responsible component to monitor the execution and resource consumptions of container through the NodeManager. From the YARN point of view, application masters are user code, means written by developers, and therefore a potential security issue can be there. This application master is written by the developer. Yarn assumes and know it very well that application masters will be buggy. Or even malicious, and therefore treats them as unprivileged code. This application master code is written by the Hadoop developer, so it can be more buggy, or even virus can be attached with that. Application master takes the responsibility to negotiate the resources from the resource manager and works with the node manager to acquire those resources and execute its task. The key benefits the application master brings to Yarn frameworks are improved scalability and a more generic framework. In MapReduce version 1, Job Tracker is having so many responsibilities like managing the task failover and allocating resources for the jobs. Scalability is excellently improved in version 2 because the resource manager, which is basically is the replacement for job tracker scheduling and only responsible for scheduling. The task of managing the jobs or application rest with the application master. If a task fails, the application master takes the responsibility to negotiate resources from the resource manager and attempt to re-execute the task. So what basically we have written in Yarn, resource manager takes the place of job tracker scheduling and only responsible for scheduling. In MapReduce version 1, job tracker having so many responsibilities like it manages the task failover and allocating resources for the jobs. The task of managing the jobs or application is with application master. If a task fails, then this application master is responsible to negotiate the resources from the resource manager. And again, it will re-execute the task. And in table, we have already seen that job tracker is the combination of resource manager and application master. So now let's see what is resource manager. So let me explain you in detail that what resource manager is. In Hadoop world, resource means RAM, memory, and bandwidth. So someone will be managing those resources, which is known as resource manager. Resource manager is the global resource scheduler which executes on the master node of the cluster and is responsible for negotiating the resources of the system and also keeps a track on the heartbeats from the node manager. The resource manager is the master and manages the entire cluster. Resource manager knows it very well that where all the slave nodes are located and how many resources they have, and that is basically the concept of rack awareness which we have already seen. It runs many services. The most important is the resource manager which decides how to assign the resources. The resource manager is primarily a global resource scheduler. The resource manager having a pluggable scheduler that is responsible for allocating resources to the various kind of running applications. Examples of scheduler can include a fair scheduler and capacity scheduler in Hadoop. The resource manager organizes the division of resources of the node manager. The resource manager works with application master to allocate resources and works with the node manager to start and monitor their underlying application. We can say that application master has taken some of the role of the Hadoop 1.x task tracker and the resource manager has taken the role of the Hadoop 1.x job tracker. The resource manager takes the responsibility to negotiate the necessary resources for a container and launches an application master to represent the submitted application. Application master uses a resource request protocol to negotiate resource containers for the applications at each node. Use of a YARN cluster begins with a request from the client consisting of an application. Upon execution of the application master takes the responsibility to monitor the container until completion of the job. Once the application gets completed, the application master unregisters its container with the resource manager and the cycle is completed. I hope all the concepts are clear till now.